Welcome to another aspect, a very powerful aspect of the show, Chem 101.1. This time around, our principal focus will be on orbital theory. We're going to present in a manner that you would want every topic in Chem 101 to become orbital theory. Pay attention. Most times when you go to some Pentecostal churches, their pastors normally start with past miracles. They tell you they have gone to a place the blind saw. In some other places, the cripple walked and all that. Why are they saying those things? Is it because they want you to be clapping for them? The answer is no. They say those things because they want to build your faith. The reason is that it's only when you have the faith that the miracles will begin to come. Why did I say so? By the special grace of God, the Guru has got what it takes to take you through this aspect of this course. So all I need from you is your maximum cooperation. You will enjoy it. Look at this word, orbital. Orbital is a point. An orbital is a point. A point on a shell where electrons are most likely found. Remember, when we were discussing basic atomic structure, if you have gone through that lesson, we are saying something that electron revolves around the shell. Electron revolves around the shell. But today, we are going to see that as electrons are revolving around the shells, they occupy certain points which we call orbitals. No wonder I said that. An orbital is a point on a shell where electrons are most likely found. What do I mean by that? If you have a house, in your house, you are supposed to have a room. If somebody comes to your house, the person goes to your room to locate you. In an ideal situation, your room is supposed to be a portion of your house where you're most likely found. Your room is supposed to be a place in your house with the greatest probability of locating you at any time t. In other words, whereas you have a house, this house can be likened to the shell where electrons revolve around in an atom. In your house, you have a room. This room can be likened to the orbital containing the electrons on the shell, the main energy level where they are found. So whereas we refer to the shell as the main energy levels of the electrons, the orbitals constitute what we call the energy sublevels. That means the energy levels existing within the main energy level, the shell. In a nutshell, an orbital is a point. It's nothing else than a point. Your definition of an orbital must have it as a point, not a line, not a curve. A point on a shell where electrons are most likely found. A point on a shell with the greatest probability of locating an electron. A point on a shell with the highest chance of finding an electron. A point on a shell where an electron stays while it revolves around the shell. That is what we identify as an orbital. Now return. These orbitals exist in various types. I'm diving into what I call classification of orbitals. Remember, anytime you want to classify, whenever you want to classify something or anything, you must choose what we call basis for classification. If somebody says, go and classify 100 level students for me. Go and classify 100 level students. A good student will ask a question. DeGuru, did you say I should classify 100 level students for you? Yes. Then the question will be, how do you want me to classify them? Because that instruction is a bogus one. Too open. A good student will want to know the yardstick, the criterion, the basis that he or she can be used to classify the 100 level students. The reason is because a class of students can be classified based on their heights. You have the tall and you have the dwarf. The yardstick for classification is height. We can classify based on color. The fair, the dark. You can classify based on level of intelligence quotient. You have the guru and you have the mugu. So the question here is, whenever we want to classify, there must be a criterion for classification. That truth equally holds the classification of orbitals. When we want to classify orbitals, we do that using three criteria for classifying orbitals. 1, their shapes. 2, their energies. 3, their carrying capacity. Carrying capacities. So what's the news? We can use three criteria to classify orbitals. These points containing electrons. These points on shells where electrons are most likely found. We can classify them using three yardsticks, using three ways: their shapes, their energies, and their carrying capacities. That means the maximum number of electrons they can carry, the maximum number of electrons they can contain. That's what I mean by carrying capacity. Now, based on shapes, we can classify these orbitals as S, P, D, or F. The S orbital is spherical in shape. Spherical in shape. The p orbital is dumbbell. The d orbital is double dumbbell. We can simply say that the f orbital is complex. S orbital is spherical in shape. P orbital is dumbbell, like figure 8. D orbital is double dumbbell, whereas the f orbital is complex. What are we using to classify? Shape of these orbitals. They vary in their shapes. They differ in their shapes. So that can stand as a major yardstick for their classification as SPD or F, sharp principal diffuse fundamental. SPDF. That is classification based on shape. And of course, when you say that something is spherical, like S orbital is spherical in shape, an object that is spherical in shape can only have one orientation in space. If you have a football, and I drop this football on this floor, looking at that football, you can hardly say whether it's lying horizontally or vertically, because of the configuration, because of the shape, spherical. So it has only one orientation in space. But like figure 8, the dumbbell, the shape of p orbital, it can have three possible orientations. It is vertically oriented in this manner. If I keep it like this, it is horizontally oriented. If I keep it in an inclined manner this way, we have a new orientation. So there are three possible orientations of p orbital. In line with each shape, we have py, we have px, and we have pz. No wonder when we are representing the orbitals in block form, for s orbital that has only one possible orientation in space, we represent that with just one block. But for p orbital, double, that is dumbbell in shape, with three possible orientations in space, we can represent that using three blocks. Talking about px, py, and pz. Let me also remind you that d orbital, double dumbbell, has 5 different orientations in space. 5 different orientations in space. You talk about the dxy. You talk about the dxz. You talk about the dyz. You talk about the dx square minus y square. And of course, you talk about the dz square. The 5 different types of d orbital with 5 different orientations in space. So if I'm to represent the d orbitals using block form, I am supposed to represent d orbital with how many blocks? 5 blocks. 5 blocks. 1, 2, 3, 4, and 5. And if I must remind you, though we are coming to that, there's what we call Horn's rule of maximum multiplicity. We also have the Pauli exclusive principle. We are going to discuss all of them in details. But in the meantime, not more than 2 electrons can appear in an orbital. And both of them must have opposite spin. That is Pauli exclusive principle. Not more than 2 electrons can occupy an orbital. So you can have 1 electron in an orbital, you can have 2, but no more than 2. And when there are 2 of them, they must have different spinning effect. If one is spinning up, the other must be spinning down. That's what Pauli is trying to tell us in his principle. Not more than 2 electrons can occupy an orbital, and both must have opposite spin. It simply means that the s orbital can take maximum of 2 electrons because it has only 1 block. The p orbital can take maximum of 6 electrons, where each of the 3 orbitals that make up the p can contain maximum of 2. Now, what's the implication? The d orbital takes maximum of how many electrons? 10 electrons, because there are 5 types of d orbitals. There are 5 possible orientations of d orbital in space. So if each of them takes maximum of 2 electrons, that means that d orbital as a type of orbital takes maximum of 10 electrons. Okay. Don't forget that the shape of f orbital, I said, has not been described. It's complex. But let me remind you that f orbital has 7 different orientations in space. So if we are to represent the f orbital in block form, I am supposed to represent it using 7 blocks. So should somebody ask you, what is the maximum number of electrons f orbital can take? If there are 7 types of f orbital, each containing maximum of 2 electrons, that means that f orbital can take a total of how many electrons? 14 electrons maximally. Remember where we are. We are classifying orbitals. We can do that using 3 criteria: their shapes, their energies, and their carrying capacities. We have just classified them using their shapes. Whereas s orbital is spherical in shape, p orbital is dumbbell, d orbital is double dumbbell, and f orbital, like I said, is complex. Now let's go to another aspect of the classification, classifying these orbitals based on their energies. And I will make just life very easy for you. As a matter of memorandum, I will only arrange them in their order of energy for clarity purpose and avoidance of doubt. And this is where they will bother you with in the examination. Chem 101.1. If I am classifying them based on their energies, S, P, D, F, and then watch the direction of my arrow. This means increasing energy. Increasing energy. Increasing energy. And if you understand the direction of this arrow, it means that whereas the s orbital has the minimum amount of energy, the f orbital has what, somebody? The maximum amount. So this person has least energy. And this person will have what, somebody? The maximum energy. It means that the energy of F is greater than the energy of D, which is greater than the energy of P, which is of course greater than the energy of S. So S has the least, whereas F has what, somebody? The maximum. All right, let's progress. That is classifying them based on their what, somebody? On their energies. Now let's return to how we can classify them using their carrying capacities. That is maximum number of electrons they can do what? Contain. All right, let's go there. Pay attention. It's a very delicious topic. Integral part of Chem 101. Once you know it, you can begin to teach those who teach you. Once you know it, you'll be very, 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 very happy with yourself. And the chemistry itself, the course we are talking about, will just be academic more to you. How can we classify them? Using their carrying capacity. Carrying capacity, the maximum number of electrons they can carry. Indirectly, we have mentioned that S orbital takes maximum of 2 electrons. P orbital takes maximum of what, somebody? 6 electrons. D orbital, maximum of 10 electrons. And of course, the F orbital takes maximum of 14 electrons. That is how we can classify them using their carrying capacities.